Welcome to Phet Atom Builder. Now we've been learning about atoms and the fact that there are many different types of atoms and each one of them has a unique structure that determines their identity. So we're going to be using this to look at how we build an atom, how we put it together, and also using it to take that information from the periodic table of elements and use that information to figure out what the structure of an atom is. Then lastly, if you have time, you can play a game. So first of all, when you come to this page, I want you to click Atom and go into the basic atom builder. Now this is what you'll see at first. Now before you do anything, I want you to click Stable, Unstable, because that's really important. Remember how I said that atoms can be very unstable if you don't have babysitters? Well, you're going to see what that means now. So make sure you click that. Don't really worry about the net charge, but you can definitely put down the mass number here. Oh, actually, if you put down this net charge, yeah, open that up actually, because remember all atoms have an overall charge of 0, which means you have to have equal numbers of these protons and these electrons to cancel each other out. So if you don't have a net charge of 0, then you've got an unbalanced atom. So let's go ahead and start with adding one proton, which will give us the very first and smallest atom, and it shows you where it is here in the periodic table. That's hydrogen, and yes, that's stable just as it is, but see his net charge here? It's +1. So in order to get him back to 0, we need to add in an electron, and as soon as you do that, his net charge is 0. So that's a hydrogen atom. Okay, now if we add another proton to this, that becomes helium, but look, it's unstable. See how it's shaking around? These two are positive charges. They are repelling each other. They don't want to be in there together. Here it is on the periodic table. The only way to help him become more stable is to add some of those neutron babysitters. So if I add a neutron there, all of a sudden that becomes stable, and I could even add another one and it'll still be stable. So we have one babysitter for every proton. However, look at the net charge. It still has too many positive charges and not enough negative charges. See here? That positive and that negative cancel each other out, but here's a positive and no negative to cancel it out. So if I put in another electron, there we have a neutral, stable, no charge atom. That's what helium looks like. Okay? Now you can keep doing this sort of thing by adding a proton and then seeing how many how many neutrons you need to stabilize it, how many electrons you need as well, and just play around with it and see how it changes what element it is, and just to get an idea of how you have to balance things out using neutrons and electrons every time you add a proton. It's really important that you understand every time I add a proton, it changes the identity of the atom. Look at that. If I take this proton out, that becomes lithium. If I add a proton in, see my periodic table up there? Look at what happens when I drop it in. It turns into beryllium. So every time you add a proton, you change its identity. Okay? Look at the periodic table. Every time I add a proton, I'm changing its identity. And then in order to make that stable, I have to add electrons and neutrons. So once you've played with this a little while and figured out how to stabilize things, you can go over to the next part of this game. So stop the video there, go and have a play with this, and when you're ready to come back and go over to the the periodic table symbols, start the video again and watch it. Okay. Now we're going to be looking at how this relates to the symbols that are on the periodic table. So here's what it looks like. We've clicked this symbol link here. First of all, I want you to click the stable unstable button so you can see whether or not it's stable. And we're going to start building an atom again. But this time, when I add in some protons, it's going to show me what the symbol is on that periodic table. This is what it looks like, the numbers and that it gives us on the periodic table. So if I put in 3 protons there, that makes it lithium. Now right now I have a charge of +3, which is unbalanced. So I'm going to have to add in some electrons to balance that out. And look what happens to my numbers. That tells me I've got no charge, I have 3 protons, and a mass of 3. Now, unfortunately, this little guy here is unstable. In order to stabilize him, I have to use the neutrons, at least one babysitter per proton, and you get a stable atom. Now look what's happened over here. It's got a 6 here and a 3 here. That's because the identity of an atom is determined by how many protons it has. It has 3 protons, lithium. That's what its number here is. Okay, we call that the atomic number because it has 3 protons in it. But its mass, now these little electrons here, they look big here, but in reality they are like the tiniest pinprick you can imagine. Okay, they have basically no weight. They don't give the atom any real mass. The mass comes from these guys, and there's 1, 2, 3, 4, 5, 6 of them, and they weigh just over 1 atomic unit. So roughly 6 of them equal 6 atomic units. So its mass is 6, but its atomic number is 3 for the protons. So as you go and change these guys to different elements, you have to stabilize it by adding extra babysitters, and you'll notice that the atomic number changes and the mass changes. Okay, now look at this one. He's still not stable. I'm going to have to add another neutron there. Now he's stable. I actually have to have more babysitters than protons in this one, but my charge is +1. I need to add another electron. Now when I add an electron, see if the mass changes. Nope, it doesn't change because they have basically no mass. So don't even worry about counting them up for mass. You just need to have them cancelling out charge. And that's how we play this part of the game. Pause the video, give this a go, and then you can come back and I'll show you how to do the periodic table game over here. Alright, you get to choose your game here, so let's see what these are. So if I pick this one first, it says find this element. Well, it's got 1 proton in the middle. So if it's 1 proton, it's going to be the very first element on the periodic table, hydrogen. Now it's asking me, is it neutral or is it an ion? That ion means does it have charge? So if it's neutral, it'll have equal amounts of protons and electrons. 1 proton, 2 electrons. I don't think it's neutral. I think that has charge. It's an ion. And then you just go check. Yay, done it. Okay, then you go next and it'll give you another one. 12 neutrons, 10 protons. Now this is for people who are really getting into the periodic table, but I'm going to show you how it goes. It literally, you count it up, everything in order. So hydrogen is 1, helium is 2, back over to the next line, 3, 4, 5, 6, 7, 8, 9, 10. Neon. Now it says it has 10 electrons. So if it has 10 protons and 10 electrons, it's neutral. Let's see if I'm right. Yep. Okay. My next game is this one here where you have to balance them out. Here I have to go and say what the overall charge is. So if I've got 8 protons and 8 electrons, I think my overall charge is going to be 0. Yep. So that's all that one is about. This one here I have to guess, I guess here, what the overall charge is. If I have 1 positive and 2 negatives, I'm going to say that my charge is going to be a -1. Let's see if I'm right. I am. You give that a go. Last but not least, no idea what this is. Oh, I have to fill in the periodic table symbol. So 8 protons. Now which one do my protons go in? The mass. Sorry, not the mass, the atomic number. That's this one down here. I got 8 protons. Now it says I've got 9 neutrons. Now remember, this is my mass up here, and that's the protons and the neutrons. So my mass is going to be 8 plus 9. 8 and 8 is 16, plus another 1 is 17. Let's see if this is right. We'll go right up here. Then 10 electrons. If I have 10 electrons and 8 protons, that means I've got 2 extra negative charges that haven't been cancelled out. So it's going to be like that. Check. Done. Okay, give those games a go. I'll talk to you later.